In the next stage, I'm going to build up the quadrature sampling encoder and the driver circuitry. As I mentioned in the earlier video, the QSE is implemented using an FST3253 multiplexer, demultiplexer, and acts exactly the reverse fashion to the receiver circuitry. So it takes I and Q signals that are at the audio frequency, and it upconverts them using the local oscillator, which is also in quadrature. It upconverts them to the RF frequency single sideband. So then that signal is fed through here to a driver, which further amplifies the signal, into this transformer here, which is configured in the push-pull configuration, and that goes out to two FETs, which are acting as the push-pull finals there. Just elsewhere on the circuitry here, we have this piece here, which sets the bias point here for the FETs. And I've seen this circuit elsewhere. If someone could explain it to me, I'd love to hear it. I understand its function. Its function is to set the bias point here, and it's enabled when on transmit and disabled on receive. But how it exactly works is a bit of a mystery to me. So anyway, if someone would like to comment on that, I'd love to hear about it. The bias point here should be around about 2.5 volts. So let's just walk through kind of the order that I'm going to build this in. So in step one, I'm going to build this bias point circuitry here, and also this piece of the circuit here. Now what this does is, on transmit, it pulls these two pins of the mux to ground, and when these two pins are pulled to ground, it's a similar circuit on the receive side. When they're pulled to ground, it actually enables the mux, so signals can flow from here through to here. When it's not pulled to ground, this is effectively an open circuit, so there's no signals can go through from here to here. In step two, I'll be pulling together this circuit here. So this is the FST3253. It's a SMD device, and this transformer and this inductor. And then step three, the final step, will pull together this part, which contains this driver transistor here, and then the push-pull transformer here, and this is a binocular core. So this is a binocular core. These two here are both T36s. This guy here has 22 turns and 11 turns by filler. This one has 20 turns on it. So we'll be able to test after each section, and this is really the penultimate video. The next stage will complete the whole of the transmit circuitry itself, and then we'll be able to hook it up to HD SDR and get it on the air. All right, I'll start the build now. Like I said, I'll do 1, 2, and 3, and I'll test after each section. So we're starting with this section here, and we'll be back pretty soon. So I thought I'd just show the installation of the FET. This is a B170 FET here. Let me just see if I can get it underneath the camera. And they are static sensitive, so you've got to make sure you ground yourself before touching them. And then with this particular configuration, they need to be bent backwards so that when the heatsink goes on them, these do get hot, it actually fits flush. So there's going to be, just to explain this, the two final FETs go here and here, again bent backwards, and there's a nut that goes through here, and then there's a heatsink on top. So when you're installing these, you need to make sure there's enough clearance right here for the nut to go through. So I need to push that down a little bit more, I think, before soldering it in place. It's a fine line, because if you don't put it far enough back, I'm probably going to have to bend those at a greater angle there. So let me just do that. So I'm just bending these at a closer to 90-degree angle, so that they actually fit in the holes intended. So let's see if that fits. I mean, you can't get the side wrong here. The flat side of the FET goes upwards. So I think let's just see how this goes. Bear with me here. So there we go. So you can see I've installed it, and there's enough clearance right here for the nut to go through. So let me just get that straightened up. Then we'll turn it over and solder it in. Best to do just one lead to start with, and then you check to make sure it's right. As you can see, that looks okay. And as I solder this, I'll apply some pressure from the other side to keep it flat. So there we go. And then finally this guy. Let's have a look at the finished product there. So the flat side's up, and there's more than enough clearance right here for the nut to go through. So that's installing that, and the BS170s from the other side fold over in exactly the same fashion. So the bias circuitry is now installed, and we can go around and probe a few of the different voltages on the circuit. So I've got my trusty multimeter on the left-hand side there, and we can have a look around. So I'm using the test button in config Softroff to so you can see that button right there, PTT. I press that, and that simulates transmit turned on, and I release it, and that simulates transmit turned off. So let's get both of these in focus here, and we can probe around on the circuit. So starting with the PTT turned off, first let me probe this point right here. So I'll probe with TX on and TX off. So that point there is right here on the circuit. So right here, so you can see with TX turned, move this, pan this over a little bit. So with TX turned off, that's 0.19 volts. With it turned on, it's 11.89 volts. So that's correct. So again, PTT off, 0.2, around about 0.2 volts. PTT on, 11.89 volts. So that's this section right here, probe first. What we'll probe next is this point here. So this point here sets the bias for the Q7 and Q8, the finals, the FETs. So that point is, bear with me here, it's best place to get it is this diode right here. So you can see with, let me get my hand out of the way, with PTT turned off, that's pretty much close to 0 volts. And with it turned on, around about 2.8 volts. So that's, again, around about expected. So now let's finally probe this point right here. And just a quick note, on the previous builds I missed out on installing resistor R29, so you do have to install that. It connects this point here, you go through R29 and then that goes up to 5 volts. If you don't put that in circuit, it won't work. So probing that is the point right, let me get my hand in here. That's the point right there. So you can see now I have PTT switched off, and with PTT switched on, sorry, that is PTT switched off. What we want to see here, again, this is the point that connects to pin 1 and pin 15 of FST3253. So on receive, we want the mux disabled, because this is the transmit part. So you disable that by bringing pin 115 high. And you can see that there, 5 volts high. So with PTT turned on, that goes down to, well, pretty close to 0 volts. So that's step 1, all checking out there. I'm going to move on now to step 2, which is installing the FST3253 and transformer T2. So let me just bring that onto here. So installing this guy, installing these resistors here, this transformer, this inductor here, and then we'll probe around after that, again simulating an I and a Q signal in through here. So that's next.